All right. This problem is two sum. I'm going to be doing it in Java. It says given an array of integers, nums, and integer target, return indices of the two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. Then they give you some examples. So they give you an input array with the elements 2, 7, 11, and 15, and the target is 9. We get an output of 0 and 1 because the indices 0 and 1 is what we're going to have to add together to get to 9. They give you these two examples here, and then they give you a list of constraints. So the length of our nums array is greater than or equal to 2, but less than or equal to 10,000 nums of I. So the values that are going to be inside of the array are going to be greater than or equal to negative a billion, but less than or equal to a billion, and our target as well. So it's going to be greater than or equal to negative a billion, but less than or equal to a billion, and only one valid answer exists. It's trying to see if we can come up or if you can come up with an algorithm that is less than O of n squared time complexity. Okay, so I'm going to show you two approaches. The first approach is the brute force approach, and it has a time complexity of O of n squared, and it has a constant space complexity, or the space complexity is constant because the only memory we're going to have to allocate is for the return array, which is only two values. And the runtime is, or the time complexity is O of n squared because we're going to need to use two for loops, one to act as the base number, and the other for loop is going to iterate over the other numbers and add it to the base number. Now, with the second approach, we're going to use a map. So, since we're going to use a map, we're going to have to allocate memory depending on however many elements we need to add to the map. So, we're going to have a space complexity of O of n there, and as far as time complexity, it's going to be O of n as well because we're going to only use one for loop to iterate over the array once and add the elements to the map. All right, so enough talking, let me show you. So with the brute force approach, we start off with the for loop. So for int I is equal to 0, I is less than the length of our nums array. And we're going to increment I, and then we're going to do another for loop. So int j is equal to I plus 1. J is less than the length of our nums array also, and then we're going to increment j. And then we're going to see if nums of I plus nums of j is going to give us our target or is equal to our target. And if it is, then we're going to return a new integer array with the values of I and j. Now, if we don't add two numbers to get to the target, or we don't find two numbers to add to get to the target, then what we're going to have to do is throw a new illegal argument exception, and then we're going to say that the target was not found. All right, so what's going to happen here is I'm just going to use example 2 as the example, I guess. So we're going to have one for loop that's going to act as the base. So it's going to start at the 0th index, so the first element. So it's going to start right here. And this for loop is going to iterate over the rest of the elements. So that's why it's I plus 1, because 1, we can't use the same element twice, and we only have, well, yeah, that's pretty much it. We only, um, or we may not use the same element twice. Okay, I kind of got confused there. All right. So since we can't use the same element twice, we have to add 1 to whatever index we on from I. Because whatever this is, we have to start obviously 1 over. So that's why we have to add 1 here. So when this is 1, this is going to be 2. So here we would beat here, and then we would start from here, adding 4 to 2, and then that's when we will get the target. All right. So let me run this to make sure it even works. Okay, this would hurry up. Accept it, and then now I'm going to submit this. Okay. Yeah, so as you can see, runtime 94 milliseconds faster than 15.12%. So that was the first approach. Now what I'm going to do is I'm going to show you how to do it using a map. So I'm going to leave this here because we're always going to throw this exception if the target is not found. But I'm going to delete this for loop and pretty much start from scratch. So first we're going to need a map. So map, and the key is going to be an integer and the value is going to be an integer. And we're just going to name this map, I guess, is equal to new hash map. If you don't know what a hash map is, it's pretty much just a unordered collection in which you store key value pairs. So the key in this case is going to be the value of whatever it is inside of the array. So 2 would be the key, 7 would be the key, 11 would be the key, and 15 would be the key. And the value would be whatever index they were on. So the value for 2, if this was 2, this would be 0 because 2 is at the 0th index. And then 7 would be 1, 11 would be 2, and 15 would be 3, and so on, depending on however many elements you have in the array. So now that we have our map, what we're going to do is we're going to check to see if the map contains the key of our, well, actually, we need to make the complement. I'm getting ahead of myself. So the complement is pretty much the number that we need to add to nums of I to get to the target. So targets minus, oh goodness, minus nums of I, and that is pretty much what's going to give us our complement. So nums of I, if this could be 2. 2, our target could be 9. So 9 minus 2 is 7. 7 will be the complement. So what we're going to do is we're going to check in the map to see if we have the complement already. Because if we have the complement, we can just look it up. And since the lookup time for map is constant, that's what's going to give us this constant lookup time, pretty much. So when we see if it contains the complement, if it does, what we're going to do is we're going to return a new int array with the values of map dot get complement. So wherever the complement is, whatever the index would be, because remember a map is an unordered collection, so we're going to need a way of referencing which index it will be located inside of the array. So that's what the value is going to do. So when we get the complement, so let's say 2 was the number that was the key here. So we're going to get 2 here. So 2 would be the 0th index. We're going to add 0 right here. And that is going to be the value we're going to return as a value in our int array. So I'm going to also add I here because I is the current index that we're on. So we're going to have to add whatever element we're on, or pretty much the index of what element we're on, to this one to get the target. All right. So these are, in other words, these are the indexes. I don't know why I'm making this so complicated. These are the indexes of which those values are located. All right. Now, if we don't have the complement, so we have a new map, we haven't added anything, then we're going to have to obviously add the value or the key and the value. So map dot put nums of I and also I, because that's going to be, or I is going to reference the index. And let me see, this should do good, or this should be good. Yeah, so let me run this code really quick. Hope there's not any bugs and compliments of I. Okay, so what is going on here? Map.put nums of I cannot find symbol. What does it mean you can't find symbol? Oh, okay. I'm so stupid. I haven't even made the for loop yet. Okay. So what I'm going to do is I'm going to make the for loop and then I'm going to add all of this in there. So let me just cut this right here. So Control X for int I is equal to 0. I is less than the length of our nums array. I didn't even make the for loop. Oh goodness. I plus plus. And then now I'm going to add all of this in there. And hopefully this works right this time. So let me, yeah, this should be good. Okay, so let me try this one more time. Hopefully this works right. And as you can see, it's accepted, submitted, and 3 milliseconds faster than 85.82%. So as you can see, this is significantly faster than this, or when we use the brute force approach, and we used what 2 point some megabytes, one no like 1 point something more megabytes because we have to allocate memory for our map. Now, if we run this again, we're going to get a different number because we may need to use a different number of elements. So if I submit this one more time and see, yeah, so as you can see, 42.5. So I guess we came up with a solution where we didn't have to iterate over as many elements or add as many elements to the map. But yeah, so that's pretty much it. So right now I'm just gonna go over this more in detail. So if you want to, go ahead to the next video, you can, or do whatever it is you were gonna do. But now I'm just gonna explain what this means when we add it to the map. So okay, let's say we have a map here and we have nothing in it. What we're gonna do is first we're going to iterate over. So let's just use this as an example again, and we're gonna see if it contains the complement. So let's just make our target. I don't know. Let me choose another number than 9. So what's 15 plus 11? 26. So let's say 26. All right, cool. So what we're going to do is we're going to try to add something to get to 26. So 26 minus nums of I. So this would be what, 2. So 26 minus 2 is 24. So the complement will be 24. We're going to look to see if we have 24. If we don't, then we're going to add nums of I to the map. So we're going to add 2 to the map, and the value is going to be whatever index it was located on, so 0. So we're pretty much going to do this all the way until we get to the end. So when we get to, let me just add it here. We're going to add 2, and then we're going to add 7, and then we're going to add 11. So when we get to 15, it's going to go here. It's going to say 26 minus 15, and then it's going to, obviously return 11. So we're going to look in the map to see if we have 11. We do have 11. So what's going to happen is it's going to go and it's going to return a new int array, and the values are going to be the complement. So the value of the complement, I should say. So since in this case it was 11, this is going to be 0, 1, 2. This is going to be 2, and I is going to be 0, 1, 2, 3. So that's why we would get something like, what is this? 0, 1, 2, 2, and 3. Yeah, because these are the indices we would need to add to get to our target. All right. Hopefully you guys understand that. I think next time I'm going to do Python. I don't know. Maybe JavaScript, who knows? But all right, till then.